Okay, so next we'll try to focus. Uh, we are going little closer, little in depth into the limits concept. Not in depth, I can say. Uh, the textbook definition we are trying to find the meaning. So, see, there is a function f of x. The function f of x is x minus 5. Can take any real value. X belongs to R. Except x should not be 5. But x should not be 5. So what is the meaning of this one? You can take less also, not a problem. See, there is a function which is defined in this way. The function value is x plus y. The function is x plus y. What is the meaning of the function? Function means you can say a mission. Missions are working based on a function. For example, the application of this mission is okay. This example, don't find the logic in this example, but just for your closer meaning to the reality, I'm taking this example. Let us assume there is a mission. Let's assume there is a mission. The mission is the job of a mission. I don't think this is logically suits, but only to make the meaning out of it, you can use this example. See, let us take this is one mission, and this is something called input, and if you give input, okay, it will give the output, just like that. Okay, for example, ah, see, I told you already, this is just for connecting to the concept. I'm taking this example. Don't find the logics, or we cannot say, don't find the uh, don't analyze too much on this example. Let us assume this is something, a roti mission. Okay, this roti mission, for example, if you provide some atta, if you provide the flour, so it will give the rotis. This is the job of this roti mission. Actually, every mission is working on a principle, so principle is nothing but a function. Okay, right. So what is the job of this one? For example, if you give one box of one box of uh, what we can say, for example, if you give 1 kg, I told you already, this is not a to find the meaning or logics in it. If I give 1 kg flour, let's assume that it's going to give 6 rotis. Okay, if I give x is equal to 1 plus 5 6, let us assume it is going to give 6 rotis. Okay, now if I give 2, actually it should give what? It should give 12, but it will not give, it will just add 5. Okay, whatever you give, okay, you can take a mission. See, you can take this as the main importance of this mission is you provide whatever, but I would make you, I will, okay, I will add plus 5 to that. That is my job. For example, you are giving 1 rupee, it will give 6 rupees. That's how you can think it. Okay, if I give 2 rupees, it will add, you give whatever, I will add plus 5 and I'll give you. So that is the job of this mission. So if you give 1, now you can find the logics in it, you can analyze it. So now try to pass a value of 1 to this mission. So what is the job of this one? It will take the input and it will add plus 5 and it will give the output 6. Now if I give 2, what happens? It will take 2 and it will add 5 and it gives the value 7, because 2 plus 5. What is happening? Adding plus 5 to every input. Next, take 3, 3 plus 5, 8, 4, 4 plus 5, 9. But I cannot pass 5. If I pass 5, this function at x is equal to 5, x should not be 5, he said. So x should not be 5 means you cannot take 5. If I pass 5, this mission will not work. For example, okay, now come back to the roti example. You can give 1 kg, 2 kg, 3 kg, 4 kg, any kg. You can give except 5 kg. Okay, after that you can give 6 kg, 7 kg. 5 is a problem. 5 phobia is there for this mission. You can understand like that. Okay, see, uh, yeah, 5. You cannot provide 5. Maybe it's going to start at 5. Okay, the function is not defined for 5. So what is going to, if you pass 5, will it give the output? No, because for 5 it is undefined. It will not give value. It will not make 10. Okay, so what we are going to do is, we will not take 5, but we'll take closer to 5. Closer to 5 means we will try to give 4.9, 4.99, 4.999, or we'll take the examples like 5.1, 5.01, 5.001. Okay, so we are going to take the closer values of this one and we'll find the limits. So that's where the neighborhood concept will come. Okay, so if you try to, this is to understand this example. Okay, so where this function is not defined, at 5 it is not defined, but using the concept of limits we can find the closer value, closer limit to 5. Okay, so how we are going to find it, let's see with a small example. We will understand, if you understand this thing in a graphical manner, I think that gives the better understanding, and I felt that is how we need to understand it, because see, if you are expressing something in terms of geometry, something in terms of graph, then you will feel, oh, you will realize the mathematics. That's where the realization of mathematics will happen. So let's take this. You can take negative numbers also. One, two, three, four, five, and 6. 1, 2, 4. I think it's going to give bigger values. Let's take this is 5, 10, 15, 20, 25, something. 30, 35, minus 1, minus 2, minus 3, minus 4. Okay, this is my 1, 2, 3, 4, 5, 6. Now, for example, if I pass 0, what is your value? It's 0, it will give 5. If I pass 1, what it's going to give? It's going to give 6. If I give 2, what it's going to give? 7. At 3, it's going to give 8. Okay, of course, we cannot find it exactly. 9. Okay, but at 5, is it going to give 10? No, at 5, it's not going to give any value. So therefore, we are keeping this 0. Now, at 6, it will give 11. Okay, it's going to give it like here. So now when you join this all, you are getting one straight line. Actually, it is straight line, imagine. And it's going to come something like this. Okay, right. Now, at x is equals to 5. So this is where, okay, at x is equals to 5. Now we need to focus at here. So what I am going to do is, okay, from 5, I am taking a 1 centimeter. If it is centimeter, from 5, I am taking some distance. Let us assume I am taking 0.1 centimeter at left hand side and 0.1 centimeter at right hand side. I am taking a value. I am taking a point which is very closer to 5. I am taking it is 0.1. Actually, it is not 0.1. It is even more smaller value than 0.1. But it should not be 0. Okay. So what we should take? We need to take a nearest very closer value to 5. So what is a closer value? 4.9, 4.99, 4.999. They are all very closer to 5. But I just to understand it or to view it or to visualize it, I'm taking, imagine I'm taking a left from 5, I'm taking a point at this place, that is, at this place I am going to take one point, that is 0.1 centimeter or 0.1 distance from 5 or 0.1 units distance from 5 and 0.1 units distance from at right hand side and left hand side. So this is the place I'm going to take it. Okay, so what is this? This side 0.1 and this side also it is 0.1. Now this 0.1, can I say it is a neighbor? Can I say it is a closer value? Can I say it is near to 5? Yes. So this 0.1 is called as neighborhood of this 5. Neighborhood of this 5. Can I take more than that? Can I take 0.01? 0.01 distance from 5 to the left hand side, 5 to the right hand side. See, to understand better, let's take only this. So this is 5. Now what we are taking here, Let's assume we are taking 0.01 distance from here to this side and 0.01 units of distance from this side. Let's assume that's that value is at here. Okay, to here. Okay. Now let us assume 0.01. Now what is this 0.01? Very small value. Very small. We cannot say small. It is a micro, or we can say nano. We can say more than. I mean, we can take very small, but it should not be 0. So this value. Okay. Now this is 5. Can you tell me, for example, this is one, right? Can you tell me what is the distance from here to this value? Where is this value? What is this 0.1? I mean, what is this value represents? It is, see, this is 5, right? From here to here, this is 5. And from here, we need to subtract this distance. From 5, okay, we are taking distance. We wanted to find the position of this one. To find the position of this one, what we need to do? Let us assume from here to here it is 5 kilometers. Now there is a point which is 0.1 kilometer away from 5 at left hand side. So now we need to find the distance from, we need to find this position. So this position is not 0.1, 0.1 is here. So we need to find the position of this one on the x-axis. So how to find it? From 5, if I subtract 0.1, you will get 4.9, right? So see, what we need to do is 5 minus 0.1. We should not say 0.1, sorry, 4.9. Instead of saying 4.9, it's better to express 4.9 as 5 minus 0.1 because we can generalize it easily. Okay, for example, let's try to understand in the general manner to understand it. Let us assume from here to here the distance is 100 kilometer. 100 kilometer. Now I'm taking a point which is 20 kilometers from 100. From 100 kilometers, I'm taking a point at left hand side. This is 20 kilometers distance. Okay, from here to here, this is 100 kilometer, and from here to here, I'm taking one point which is 20 kilometer. Now, can you tell me what is the distance from here to here? So this is total distance 100, and if I subtract this 20 kilometer, you will get this distance, right? So can I write this distance as 100 minus 20? Can I write this point as 100 minus 20? Can I write this is 80? So that's how. Next, this side also is taking 20. So therefore, this is the point. Now, what is this? What is the value from here to here? This is 100, up to here 100, and extra, this is 20 kilometers. So therefore, is it not 100 plus 20? Same as that. Okay. So from here to here, the distance is 5 minus 0.1, which is 4.9. And from here to here, okay, from here to here, this right hand point, that is 5 plus 0.1. This 5 minus 0.1 and 5 plus 0.1 are called, which are expressed in limits as a smaller value, and this is denoted with a symbol sigma. What do you, sorry, delta. Okay, so this is what we pronounced as delta. We have one more delta in Greek letters, same as in Greek letters. In English, we have alphabets, capital and uppercase letters, lowercase letters. So in Greek also we have uppercase letters and lowercase letters. So it is delta, and we have one more delta. This is triangle shape. So both are delta, pronounced as delta, but the symbols are different, little different. Right. So this small 0.1, 5 minus 0.1, 5 minus 0.1 and 5 plus 0.1 are, you can say 5 minus 0.1 comma 5 plus 0.1, 5 minus 0.1 comma 5 plus 0.1 are called as neighborhoods of 5. Neighborhoods of 5. So neighborhoods of 5. Okay. Next. Okay, see here we are understanding in terms of numbers, the same thing we'll try to understand for general function. Okay, because we need to uh, express, or we need to express in terms of delta. So to understand that, I'm going to take a general example. Okay, not this one. So there is a function limit where x is tending to a, then f of x is also not required, right? This is not required. Let's assume there is a function, and this is the shape of a function. Okay, now I am taking a point A here. Okay, we wanted to find the limit at A. What we need to do? We need to find the limit at A. Okay, now from A I am taking a distance of delta. So what is this point? So this is A. Therefore this point is how much? This total distance is A. From A, if you subtract this one, is it not A minus delta? Next, I am going to take another point, same delta. So this point, now see from here to here, I mean this point is A minus delta because the distance from here to here is A minus delta. What about this one? This point is A plus delta. From here to here, the distance is A plus delta because up to here A and this delta is added, total is A plus delta. Okay, so now what is this delta? So this delta is a very smaller value, but it should not be smaller means you cannot say 0. So this delta value must be greater than 0, but it is a very small value. You can say micro, nano, very small value. Must be smaller, but it must not be 0. Okay, so this A minus delta and A plus delta are what? Are they near to A? See this A minus delta is it not closer to A? This A plus delta, is it not closer to A? So therefore A minus delta comma A plus delta are the neighborhoods of A. So this is what the meaning of neighborhood in limits. So very simple, neighborhood means closer value at A. Okay, now right, next. So this is A minus delta and A plus delta. Now if you observe here, uh, let's take okay, now I am finding the limit at A minus delta. At A minus delta, this is a function. See, generally what you are doing is you are taking f of x function, right? This function, this x input x values we are placing on the x axis, on the x axis, and this f of x values we are trying to place it on y axis. Okay, now what is this A minus delta? A minus delta, what is A minus delta? X value. We are taking x value as what? A minus delta. If I pass A minus delta into f of x, it's definitely going to give some value. Okay, so let us take that value is at here. Now if you pass x is equals to A plus delta, that is also going to give a value. Maybe imagine that's going to give the value at here. So this seems to be very large, but it is not really true. Okay, just for your understanding, we are writing it. So it's going to give some value. So this is the value. So let us assume this value is something. Can I say f of a minus delta. This is something f of a plus delta, a minus delta and a plus delta. Now at a it is also going to give some value, right? At a it is going to give some value which is L. Now what do you mean by this one? uh, okay, at a minus 1 it is going to give f of a minus delta. At a plus delta it is also giving to a plus L. So if you observe a minus delta, for example, if I give little more extra value here, let's take that value is x. Okay, I'm going to take the value as x. Now this total is a, this value is x. Can you tell me what is this? Total is a, this value is x, therefore it is x minus a, right? Okay, so we are having something called x minus a. Now tell me, see once again, this is a, this is x, therefore this small space is x minus a. Okay, if this is delta, this is x minus a space. Don't you think that x minus a is greater than delta? Definitely it is greater than delta. Okay, see once again, this is delta. Now you are taking only this much. So on this delta part, on this delta part we are taking a small portion. This is actually x. Okay, this from the distance from here, I mean the distance from here to here is x, but distance from here to here is a. So what about the distance from here to here? What about the distance from here to here? This small distance is what? That is x minus a. Once again, so this distance is a, this distance is x, therefore this distance will be a minus x. Okay, sir, this is x, this is a minus x, a minus x. Okay, so we'll discuss about this one, x minus a and a minus x, little later. Okay, let's discuss about this one only. So here at f of x at a, just let us assume this value is L value. So here f of a minus delta, I mean whenever x value is a minus delta, okay, a minus delta, this function is actually trying to reach or going towards L. If I pass x is equal to a plus delta, then this same function is trying to reach to a value called L. So therefore this L is called the limit of this function. L is called as what? Limit of this function. Okay, limit of this function. Okay. Now what is this a minus delta and a plus delta? So a minus delta and a plus delta are called neighborhoods. Okay. Now can I take a minus delta as x value? Yes, you can take. Can I take x is equal to a plus delta? Yes, you can take. But we cannot take, we should not take the value of x is equal to a. We should not take a. So you can take a minus delta. You can take even more closer to a. You can take a plus delta, and still you can take a little more closer to a, but you cannot take the value of a. So a is actually deleted. So a is called as deleted neighborhood. A is called as deleted neighborhood. Okay. When a minus delta and a plus delta are neighborhoods. Okay. So this is about the neighborhoods. So here neighborhood, this is delta. Delta value is small, micro, nano, but it is not zero. Okay. Now, so this is how we can do it. That's all about the neighborhoods, and we have some. Now we can complete one more topic also here. A plus delta and a minus delta. Okay. At a plus delta, the difference between, see what is the distance from here to here? This is L, and you can see some space here. Okay, these values are because we are taking delta distance here, delta distance here, so these values are going to be same. I mean same in the sense this distance should be equal to this distance. It's going to give like that. Okay, So that distance is called epsilon. Okay, so we are also discussing about epsilon. What do you mean by epsilon? Okay, you can say it is the difference or distance between f of a plus delta and L. The difference f of a plus delta minus L gives epsilon, and L minus f of a minus delta, which also gives epsilon. So these two here, this epsilon is also greater than 0. It's very small, but it is greater than 0. That is very small, but very greater than 0.